Hey YouTube, Unkert here. In this video, I want to look at decorators in Python, and I want to use decorators to check out the performance of different functions, specifically compare list, set, and dictionary comprehensions, and then we might show like O of n versus O of n squared, and so on. One thing, if you notice the development environment I'm using is slightly different. My PyCharm was giving me some memory issues, so I'm doing this in Sublime Text. It doesn't really matter. You can use free ones like VS Code or Pulsar, PyCharm Community, or you can use paid stuff like Sublime Text and so on. Anyways, let's get started. And the first thing I want to do is import time, okay, because we're going to use that later. And then we're going to create a decorator. And a decorator is something that decorates a function. So we can wrap some stuff around a function. So let's show you the syntax. So I'm going to call this function execution time. And I'm going to take in a function, okay? And then I'm going to have a wrapper, okay? And I'm going to be able to accept star args and star keyword args so that we can take in as many arguments as we need for whatever function we're testing. All right, I'm going to have a start time, and that's going to equal to time.performance underscore counter, okay? And then I'm going to have the function, okay? I'm going to call the function, and I'm going to make sure we have the star args and star keyword args, just so we can take in any amount of arguments. And then we're going to have an end time, which is time.performance counter. Okay, and then our total time will be our end time minus our start time. After that, I'm going to print an f string and just say the total execution time was, and then we'll pass in the total time there. And at the end of this, we'll return the wrapper function, okay? So basically what's happening is here is I can test out some function in here where it's func star args, star keyword args, and I can wrap it with the start time, end time, and the calculation of the total time and the output here. And that's going to allow me to see, what's faster. So what I'm going to do here is I'm going to decorate the following functions. And the way I do that is with this @ symbol, and I'm going to say execution time. And then I'm going to put right below it my function. So first one, we'll do list comprehension. And we'll take in my list as an argument. And we'll say my new list equals, and then we'll do some list comprehension. We'll do item for item in my list, okay? And then at the end, we'll just return my new list, okay? I'm going to go down here and let's do the same thing for set comprehension. So we'll say at execution time, and we'll define a set comprehension program, and we'll say my set, okay? And then what we'll do is we'll say my new set is going to equal, we'll do set comprehension, item for item in my set, okay? And we'll return my set here, okay? We'll go down here, we'll wrap another function with this execution time decorator, and we'll define dictionary comprehension function. We'll take in my dict, and we'll say my new dict equals, and then what we'll do is we'll do k colon v for k comma v in my dict dot items. Okay, and we'll return my new dict at the bottom of this. All right, so we've got these three functions, and we're going to compare the three. Okay, so we have to create my list, my set, and my dict so we can pass these into the function. So I'm going to say my set equals and we'll do num for num in a range. And to really see the difference, I'm going to do 10 million. So we'll do a 1 with 7 zeros following it. So 1, 2, 3, 4, 5, 6, 7. Okay. And then we'll say my list equals, we'll do num for num in range. We'll also do 10 million. So 1, 2, 3, 4, 5, 6, 7. Okay. And for my dictionary, we'll do my dict equals, and then we'll do num colon num for, so both the key and the value will be the same number, for num in a range of, again, 10 million. So we'll do 1, 2, 3, 4, 5, 6, 7. Okay. Let's pull this up so you can see it. All right. So now what I want to do is call each of these functions, and maybe we'll call them a few times just to get a good comparison. So I'm going to go down here and print, let's just say list comprehension times, and then what we'll do is we'll print, actually we could just call the function, right? Because we're printing at the end, yeah. So let's just call the function here. So we'll say list comp, and we'll pass in my list, and we'll do that 3 times. And then let's print set comprehension times. Okay, and we'll call the set comprehension, and we'll pass in my set and do that 3 times. And then we will do dictionary comprehension times. Okay, and we'll do the dict comp function passing in my dict, and we'll do that 3 times. And let's now build it. Okay, so it's going to take a moment because we have 10 million times it's going through. So it's going, here we come. List comprehension times. Okay, set comprehension times are slower. And then the dictionary time comprehension times are even a bit slower than the set. So it turns out the list comprehension times are the fastest, set comprehension times are the second fastest, and the dictionary comprehension times are the third fastest. Okay. We could also get rid of a bunch of this stuff, but keep our original decorator. And let's create an O of n function. So we'll say this definite function, let's call it just O underscore n. And what we'll just do in this function is we'll say for I in range of, let's do 1 million. What should we do? We'll say I equals I plus 1. Okay, so we'll just add something to I. We won't return anything with this. And then let's also do now execution time, and we'll do O of n squared. And we'll say for I in range 1 million. Right? We'll say for j in range also 1 million. So we're getting some O of n here. No, is that 100,000? Let's see, 1, 2, 3, 4, 5. Yeah, I need to add another one. Okay, what we'll do is we'll say j equals j plus 1. Okay, and now what we'll do is we'll go down and we'll say, we'll do a print. We'll say O of n execution times. And what we'll do is we'll call the O of n function 3 times. And then we'll print O of n squared execution times, which is going to take some time. I may have to cut the video here. So we're going to do O of n squared, and we'll do 3 times. And let's build this. I may cut out a little bit in this video. Well, you see the O of n runs really fast. And actually, let's keep talking just to kind of see how long the O of n squared is going to take. So let's keep going. It's still going. It's still going. It's still going. It's still going. Okay, I may need to actually cut out some time. We'll see. Okay, I actually cut out some time and wiped out the program because as I was sitting there, I was thinking, well, we're doing, for each one of these, we're doing this a million times, and we did like 0.1 seconds for each of these. So that's like a million times 0.1. So yeah, I want to finish this video before I retire. So anyway, so yeah, we could see that the O of n squared takes a lot longer. But yeah, we can use decorators here to do a lot of things with different functions, but one is to check the performance of a function. So this is how I would do it. If you like this video, please give it a like and subscribe to the channel. Thanks for watching.